Hello students, welcome to my channel Arun's Physics Portal. In this lecture, I will discuss about the realization of an inductor using an operational amplifier. As you know, an inductor is basically a coil. As it has a large size, it cannot be incorporated in an IC chip, which has a very small size. The property of an inductor can, however, be realized using operational amplifier in an IC chip. This topic is important for MSc students of both physics and electronics and also for BE and BTech students. Moreover, it will also be found useful for GRF and NET aspirants. The complete description of this circuit is provided in this lecture for your convenience. I hope you enjoy going through it. But before we go ahead, it is useful to recall voltage divider rule, which will be used in the circuit description of inductance simulation. So we start with voltage divider rule. Voltage divider rule. Suppose we have two resistors in series. Potential is VA, the potential here is VB, and the potential somewhere in between the two resistors is V. This resistance is R1 and this resistance is R2. So as the resistors are connected in series, the current that flows through resistor R1 will definitely flow through R2. The same current will flow. So we have by Ohm's law. By Ohm's law, what we can write? We can write I equal to VA minus V upon R1, and this is also equal to V minus VB upon R2. We have to find the value of V. So we shift V to one side of the equation and the remaining term to the other side. So this gives us V into 1 upon R1 plus 1 upon R2. This is equal to VA upon R1 plus VB upon R2. Take the LCM. So this gives you V R1 R2. This is R2 plus R1, and this is again LCM is R1 R2. This is R2 VA plus R1 VB. The denominator on both sides of the equation cancel out. So what we get? We get the value of V, the potential in between the two resistors, as R2 by R1 plus R2 into VA plus R1 divided by R1 plus R2 into VB. This is the potential at a point in between the two resistors R1 and R2 when the same current flows through both the resistors, and this is known as the voltage divider rule. By applying this rule, you can find the potential between two resistors when the same current flows through them and there is no division of current. So this is your voltage divider rule. Now we see how an inductor can be simulated. So for this, we draw the circuit diagram of an inductor. Inductance simulation. See, this is your first operational amplifier, this is inverting input, and this is non-inverting input. We have a resistance here and we have a resistance here. The resistance are taken to be equal. So this is R1, so this is also R1, and this is grounded, and we have a potential Vi at the non-inverting input. The potential at the output of this op-amp is, let it be V1. We have resistance R2 here, and we have here another op-amp. This is negative input, this is positive one, and this is the final output V0. Here we have an impedance ZF between inverting input and the output of the second operation amplifier. And then we have another resistance between input and the final output. See, this is the resistance here. Okay, I take this potential to be V2, and we have here the same input goes to the non-inverting input of the second operation amplifier. Because this is a large figure, I advise you to draw this figure on a piece of paper and keep it in front of you, so that when I derive the different equations, it is easier for you to compare. So this is circuit diagram for an inductance simulation. Circuit diagram of inductance simulation. Now you see here, this part is nothing but a non-inverting amplifier. And what you have seen? You have seen that the gain of a non-inverting amplifier is 1 plus Rf by R. This you have seen. So the gain for this will be equal to 1 plus Rf by R1. So the output is V1. So V1 will be equal to from the figure shown, we have V1 is 1 plus Rf upon R1, and this is 1 plus Rf is equal to R1, so this is R1 upon R1 into, here this will be equal to, this is this will be here 1 plus Ra by R1 into Vi, and this is 1 plus R1 upon R1 into Vi. So this is 2 times Vi. This is our equation 1. Now see that the current that flows through R2, the entire current will flow through Rf. The current will flow through R2 will flow again through ZF without diminishing in magnitude, because their impedance of the inputs of the op-amp are very high, theoretically infinite. So no current will practically enter into the inverting input of the op-amp, and therefore the entire current that flows through R2 will pass through ZF. So we can here apply voltage divider rule to find the value of V2. So if you apply the voltage divider rule here, what do you get? You get applying voltage divider rule, we get the potential V2 will be equal to ZF divided by R2 plus ZF into V1 plus R2 divided by R2 plus ZF into V0, or this gives you V2 as 1 upon R2 plus ZF. This is common factor in both of the terms, and then this is ZF into V1 is 2Vi, put the value of V1 2Vi plus R2 into V0. This is our equation 2. As V1 is 2Vi. इसलिए मैंने कहा था आपको कि आप फिगर को ड्रॉ करके पेपर पर रखिए सामने में, so that you have no difficulty in following the steps that I am doing. So now V0, the output will be how much? V0 will be A times Vi minus V2. Clear? So this is A times Vi minus, put the value of V2 from equation 2 here. So this is 1 by R2 plus ZF into ZF into 2Vi plus R2 into V0. So we have V0 on both sides of this expression. So transfer V0 to the left hand side. So what do you get? You get from here V0 into 1 plus A upon R2 plus ZF into R2 here. Clear? And this is equal to A times A upon R2 plus ZF into R2 plus ZF minus 2ZF into Vi. Into Vi. So this is, I add it again to save a space, R2 plus ZF R2 plus ZF minus 2ZF into Vi. Okay. So this gives you V naught into R2 plus ZF plus AR2 divided by R2 plus ZF is equal to A upon R2 plus ZF R2 minus ZF into Vi, and therefore V naught is equal to, the denominator cancels on both sides of the expression, so this cancels out. So this is A upon R2 plus ZF plus AR2 into R2 minus ZF into Vi. We divide both numerator and denominator by A, so this is 1 upon R2 plus ZF upon A plus R2, and this is R2 minus ZF into Vi. So because A is theoretically infinite, so this term tends to 0, and therefore this term tends to 0 as A tends to be infinity theoretically. So we have V naught is 1 upon R2 into R2 minus ZF into Vi. Okay? So therefore, what we get? We get V naught as Vi minus ZF upon R2 into Vi. By simple algebraic manipulation, we can write V naught minus Vi upon R3 is minus ZF upon R2 into Vi upon R3. On dividing throughout, by R3. So what is this? V naught minus Vi is the current that flows from output to the input. So because we have shown the direction of current flowing from left to right, from input to output, it is just the other way around. So I put a negative sign here. So this is minus II is equal to minus ZF upon R2 into Vi upon R3. So the input impedance, what is the Vi upon II? Input impedance. So I write the input impedance is Vi upon II. I write as Zi. This is equal to, this is equal to R2 R3 upon ZF. If I take ZF as a capacitor, then what will happen? If ZF is 1 upon j omega c, then the preceding equation gives ये क्या दे रहा है? ये दे रहा है ZI इज इक्वल टू R2 R3 डिवाइड बाई 1 अपॉन j ओमेगा c, और द इनपुट इम्पीडेंस ZI is equal to j omega c R2 into R3. We can also write it as ZI is j omega R2 R3 into C. I call it equation 3. So if we take L equivalent is R2 R3C, then the input impedance of the circuit is ZI is j omega L. This is your equation 4. So this is how an inductor can be realized using operational amplifier. You see from here that we have taken L equivalent equal to R2 R3 into C. So impedance of a capacitor is XC is 1 upon j omega c, whereas the impedance of an inductor is XL is j omega L. We have seen that ZI is j omega R2 R3 into C. So I call this as my L equivalent. Why? Because it has the form of the impedance of an inductor, j omega L. So I take this term within the bracket as L equivalent. So if I put there a capacitor in place of ZF, the input impedance behaves as an inductor. So an inductor can be realized using an operational amplifier. So इसको समझने के लिए ज़रूरी है कि आप डायग्राम को पहले अपने सामने रखिए, और उससे मैंने जो निकाला है स्टेप बाय स्टेप, तो आप उसको फॉलो कर सकते हैं आसानी से. So मैंने जैसे पहले बताया कि an inductor has a large size and this cannot be incorporated in an IC chip which is very small in size, but its property can be achieved using operational amplifier, and we have shown that. If you use a capacitor in place of ZF there, you get the property of an inductor. I assume you like this presentation. यदि आपको ये लेक्चर अच्छा लगा हो तो लाइक करें, शेयर करें और मेरे चैनल को सब्सक्राइब करें. See you next time with some other topic of interest. Till then, goodbye. Thank you for watching.